Good morning friends. In the previous video we have solved a different problem of T section for centroid and center of gravity, and in this video we are going to solve a composite figures for the centroid. Let us start the problem. Using the analytical method, determine the center of gravity of the plane uniform lamina as shown in figure. Here we have given a composite figure. First of all, by observing the diagram, we can know that here we are having three simple figures. First we need to divide or split these given figure into three components as square, semicircle, rectangle and triangle. First I am considering the square as first figure, semicircle as second component and triangle as third one. By observing the figure, first we need to split or divide the given figure into three components. First, divide or split the given diagram into ones or three plane figures. After dividing this figure into three sections, we are going to calculate the center of gravity for this figure. We all know that when we are studying about T section, we have studied that if the symmetry has been formed, means we need to calculate the y bar or x bar. Coming to this diagram, here the symmetry is not forming either in x-axis or in y-axis, so that we need to calculate both x bar and y bar. For calculating the center of gravity, we are having an equation that x bar is equal to a1x1 plus a2x2 plus a3x3. As we are having here three components, we have splitted the given equation into, we are calculating here the three areas, a1 plus a2 plus a3. And as the given figure is not symmetry in y-axis or in x-axis, therefore we need to calculate both x bar as well as y bar. For calculating the y bar, we are having an equation that a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. For calculating these x bar and y bar, we have got an equation here. For x bar and y bar, we are going to solve this centroid for the composite figure. First, let us take the first area 1. What is the area 1 which we are taking here from the diagram? Means we are taking here the rectangle. First one, area 1, we are taking the rectangle. Therefore A1 is equal, for calculating the rectangle we know the area A1 is equal to L into B is equal to length here 5 centimeters also has been given. L means we are having 10 into 5. 10 into 5 is equal to 50 centimeter square. Y1 is equal to, for Y1 in the yesterday video I have explained you how to take the y1 y2s and x1 x2s. For considering for y1 we need to go from the bottom onwards, bottom to top. Y1 is equal to 5 by 2 is equal to 2.5 centimeter. Next I am going for area 2. Area 2 is nothing but of semicircle. For calculating semicircle we are having an equation that A2 is equal to pi r square by 2. Pi into what is the radius we are having here is that 2.5 whole square by 2. Hence I have got A2 is equal to 9.82 centimeter square. And now we are trying for y2. Y2 is equal to, we are having formula for calculating the semicircle. Y2 is equal to 5 by 2 is equal to 2.5 centimeter. Area 3. Area 3 is of triangle. For triangle we are having an equation half b into h is equal to the diagram. Half b means nothing but of 5 into 5. Half into 5 into 5 is equal to 25 by 2 is equal to 12.5. We have got the three areas A1, A2 and A3. Now we are calculating the y bar using the relation y bar is equal to A1 y1 plus A2 y2 plus A3 y3 by A1 plus A2 plus A3. A1 is equal to, what is the A1 value we are having here is 50 centimeter. 50 into y1 we are having here, y1 is 2.5 2.5 plus A2 we are having here 9.82 into Y2 we are having here 2.5. Y2 means 2.5 plus we are having A3 is equal to 12.5 into what is the Y3? Y3 is equal to 5 plus 5 by 3 means Y3 we are considering from bottom as the Y3 value is 5 centimeters. 5 plus 5 by 3 we are taking here 5 plus 5 by 3 6.67 centimeter. Therefore Y3 is equal to 6.67 by 50 plus 9.82 plus 12.5 is equal to 3.22 centimeter. Similarly, we are trying for X bar. First we are starting from area A1. Area 1 rectangle. A1 is equal to 50 centimeter square. X1 is equal to 2.5 plus 10 by 2 is equal to 7.5 centimeter. X1 means how we are taking here the X1 value means here we are taking the X1 for this rectangle. We need to take the axis from left to right. We need to take the axis from left to right. As we are taking for rectangle, first we are having some value that 2.5. That 2.5 I have written here plus I am doing for this rectangle for which figure we are doing that should be multiplied by 2 means 10 by 2 is equal to 7.5 centimeter. Area 2. Area 2 is semicircle. For semicircle we are having area A2 is equal to 9.82 centimeter square. X2 is equal to 2.5 minus 4r by 3 pi means as we are having here for semicircle in X bar we are having the value 2.5. In these 2.5 we are minusing the 4r, we are minusing 4r by 3 pi which we are having the value for semicircle. 2.5 minus 4r by 3 pi is equal to 1.44 centimeter. Now considering area 3 triangle. A3 is equal to 12.5 centimeter square. X3 is equal to, as we are considering for x3, we need to go from left to right. We are having here 2.5. In the meanwhile, we are having here 5 plus up to this triangle we are having 5. For which figure we are doing, that should be multiplied, that should be divided by 2, means 2.5 plus 5 plus 5 by 2. 2.5 plus 5 plus 5 by 2 is equal to 2.5 plus 5 plus 2.5 is equal to 10 centimeters. Now, using the relation x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Substituting the values which we are having, that 50 into 7.5 plus 9.82 into 1.44 plus 12.5 into 10 by a1 means 50 plus a2 means 9.82 plus a3 means 12.5 is equal to 54514.14 by 72.32 is equal to 7.1111 centimeters. Hence, we have proved or calculated center of gravity for the given composite figure. Thank you.